The second skill in section 6.13 is about trying to integrate across an infinite discontinuity. So one way to have an improper integral is that you're trying to take an integral out to infinity. And the other way of having an improper integral is that you're trying to take an integral across an infinite discontinuity. So here's an example of a improper integral that doesn't look improper right away. You have to kind of think about it before you say, oh yeah, that's improper, because if you plug in a 3 here, your function would be undefined. So your integrand has a discontinuity at x equals 3. It'd be 1 divided by 0, so it's an infinite discontinuity. And sometimes these have an answer and sometimes they don't. So let's work on trying to decide. So again, the way we deal with infinity in calculus is we say, well, 3 is a problem, so we're going to do limits. So we take the limit as b approaches 3 from the negative direction. And it's from the negative direction because we're going from 0 to 3. So then we're going to do the integral from 0 to b of 1 over root 3 minus x dx. And the integral itself looks like it's a good candidate for a u substitution. U is equal to 3 minus x. So when I translate my limits of integration, my lower limit of integration would be 3 minus 0, which is 3. And my upper limit of integration would be 3 minus b. And then this is u to the negative 1/2. And the reason it's negative is because du is negative dx. Now we do an antiderivative, so that'd be negative u to the positive 1/2 divided by 1/2, which is times 2. Oh, and then we're doing the limit as b goes to 3 from the negative direction. And so then we plug in our limits of integration, and we have negative 2 square root of 3 minus b plus 2 square root of 3. And we're doing the limit as b goes to 3 from the negative direction. 3 minus 3 would be 0. The square root of 0 would be 0. So this section is going to go to 0. And we're also relieved that we're not approaching 3 from the positive direction, because then we know that we're not trying to take the square root of a negative number. So this negative direction was a relief to us because it meant that we weren't trying to do 3 minus a number a little bit bigger than 3, and that would have messed up our square root. So this area right here is 2 times the square root of 3 big. Occasionally, your vertical asymptote will happen on the interior of your interval. And in that case, it's really easy to forget to check. 1 over x cubed has a discontinuity at x equals 0, so that's going to be a problem for us. And just like when our limits are going to positive and negative infinity, we have to split this into 2 separate integrals. So we're going to do the limit as, we're going to do the integral from negative 2 to b as b approaches 0 from the negative direction. And we're also going to do the limit as a approaches, so we're going to go from a to 3 as a approaches 0 from the positive direction. So it's still additivity because they're both approaching 0, or still adjacent integrals as a approaches 0, but we're making sure that we're approaching 0 from the correct direction, and we have to split it in 2. Okay, so now we're going to do our limits of integration. So, our antiderivative, so this would be x to the negative 2 divided by negative 2. So negative 2 to the negative 2 would be 4 to the negative 2. As b approaches 0, if I rewrite this a little bit, I have 1 over 2b squared. And this would be minus 1, oops, that's not to the negative 2 power, that's to the negative 1 power because I already squared it. But as b approaches 0, this part is going to approach infinity because we're taking negative 1 divided by 0. And so this integral, and we don't even have to look at the other half, this integral diverges because we ran into an infinity as we were looking at our limits. So an improper integral will diverge if either piece of it diverges. So we're done there. So in summary, an improper integral could be approaching infinity or negative infinity, in which case you set up a limit, or you could be trying to integrate across a vertical asymptote, in which case you set up a limit. If you have a vertical asymptote on the interior, it has to be 2 separate limits. And if either one of those limits diverge, you are done. The whole thing diverges.